Welcome back to Security and Privacy in Cloud. I am J. Lavanya, Assistant Professor of CAC Department. So today we are going to discuss about Unit 5, Monitoring, Auditing and Management in Cloud. And in that subtopic we are going to see is that proactive activity monitoring and then incident response. So first of all, what is meant by proactive monitoring? Yes. So proactive monitoring simply means a constantly attempting to identify potential issues before they create major challenges for your business. Since proactive monitoring anticipates issues, you can address these kind of issues before an application crashes or performance degradation sets in. So it involves continuously identifying some potential issues and whereby the IT infrastructure and application before they escalate into significant challenges. This approach allows businesses to address the problems before they cause application crashes or performance degradation. So by resolving these kind of issues early, proactive monitoring ensures smoother operations and enhances user experience. In practice, proactive monitoring detects the potential problems before the users notices and compliant, thus avoiding some business impacts. Unlike reactive monitoring, which identifies failures after they occur, proactive monitoring alerts IT administrators to issues well in advance. This allows for a timely intervention, maintaining optimal performance and reliability. So proactive monitoring means constantly searching for signs that indicate a problem is about to happen and enabling businesses to operate more efficiently and effectively. And it is the opposite of reactive monitoring. So while reactive monitoring detects the failures after something has gone wrong, whereas proactive monitoring alerts IT administrators to potential users well before the issue becomes a failure. So by avoiding these kind of business implication failures, proactive monitoring helps us to enhance the service uptime and performance that increases customer trust and enables increased efficiency in IT operations. So this is all about proactive monitoring. So what are the formal industry standards around proactive monitoring? So that is the AWS MSP Partner Program, that is the Amazon Web Service Validation, that audit checklist which contains a usual set of criteria of how AWS want the multi-service provider to proactively build the services upon the AWS and its workspaces. Okay, so what this Amazon also expects is that partners offers a next generation monitoring for the critical customer workloads. So this provides the comprehensive monitoring and alerting capabilities that cover all components and layers of the workload, not just the AWS services and resources. So this provides operators with visibility into workload, health, and performance, and proactively notifies operators of potential service impacts. So the partner has standardized approaches of collecting or integrating, monitoring, and alerting on workload health and performance data at both the infrastructure and application layers, as well as across the multiple components of the workload. So basically, this Amazon expects the multi-service provider to have monitoring in place that will detect the potential service impact so that the service impacts are avoided for the end users. So this is where the synthetic monitoring simply doesn't cut it, especially if it doesn't go beyond the lagging simulations. Amazon also expects a standardized approach for collecting, integrating, monitoring, and alerting on the workload health and performance data at both the infrastructure and application layers. Okay. And if you take the synthetic monitoring, which is useful but not sufficient for some proactive monitoring. Like many monitoring products promise to proactively monitor your business application. When you dig deeper though, you'll find that the offering amounts to little more than continuous synthetic transactions, testing on the availability of applications, desktop and network resources, and are often little more than the basic logon simulators. A synthetic transaction testing essentially uses some robot users to try and access the resources. So as synthetic monitoring runs 24/7, it may be able to detect the problems before the real users encounter them because it's accessing the application or the IT infrastructure at times when the real user may not. For example, a logon failure at 3 a.m. may be detected by synthetic monitoring because real users may not log in at that time. So they may not notice the issue until they log in at 7 a.m. However, the synthetic monitoring simply isn't it true that proactive monitoring, as all you have done, is to discover a problem that has been already occurred. True proactive monitoring should be able to detect the problems in advance, even when the users are actively accessing the applications or infrastructures being monitored. For example, in a medical analogy, using some like synthetic monitoring tool is akin to taking a temperature check on a person. When the temperature is abnormal, you know that there is an issue. But by the time you know that the temperature is abnormal, it is probably late already. The person is sick, right? So, the proactive checks of other key parameters, blood pressure, blood glucose level, etc., may provide early warning indicators of the problems. Okay, so this is all about the formal industry standards around proactive monitoring. Next topic is that what is needed for true proactive IT monitoring. So metrics like service availability and response time are important for assessing the performance versus the service level agreement. However, they do not provide proactive indicators of a problem. So these metrics are often indicative of aspects of a problem like symptoms, but the actual problem may be somewhere else, right? We have done this in a real-time application. So there are many other metrics or that can provide early warning indicators of a problem. For example, a handle leaks in an application, and second one, a gradual increase in a Java application heap usage, and third metric like a package drops on a router. Okay, like handle leaks in an application example I felt like in an Microsoft Windows. If we take application use handles, right? A handle is a unique identifier for a resource that is managed by the OS kernel. A handle can be a window or a file or a socket, etc. So the OS maintains a finite number of handles and the application use handles as needed and release them when they no longer require them. So this ensures that resources not in use are freed up in the OS. And programming errors, software bugs, or the incompatible between the software can cause the programs to hold on the handles they no longer needed. Such a scenario causes the handle leak, or the handle leaks can lead to some sluggish performance, system instability, or in extreme cases, an application or a server crash. So proactive monitoring tools monitor and report on handle leaks. Early detection of such issues can monitor and report on handle leaks. So early detection, this elevate the issue like raise a bug with the software vendor or reboot the system overnight to avoid the problem from escalating. Second one, a gradual increase in Java applications heap usage. So memory leaks can also occur in an application code. Example objects are allocated but not released. In Java application, for example, the application's memory usage limited by the maximum limit set for a heap memory, and application memory leaks result in a heap memory being utilized to its fullest. So while such issues may not lead to a server crash, the application may become slow over time, and synthetic monitoring has very limited use in such cases. By the time slowness is detected in this approach, it is likely that the users are experiencing some issues. Okay, and next one, the last is that packet drops on a router. So on a network device, it is important to track the packets discarded during the reception or the transmission, possibly because the buffer available is not sufficient. Errors on the network are also a sign of a poor network connection. While a small percentage of errors may not affect the user experience, if the issue is left unattended, the percentage of errors may increase over time and ultimately affect the service performance. Okay, and there will be some network interface like for fast internet 0. Like they will be having some sort of rules whether is the network interface operationally available, yeah, and data receive whether it is properly working or not, and the bandwidth they are using is that this maximizes the limit, and the received errors, transmit errors, and in discards, out discards, as well as unicast pack is received, unicast pack is transmitted. Okay, so all these kinds of networking tab, including microtic routers, river bed steelhead, like Jet Nexus, load balancer, routers and switches from Freecom, Dell, Cisco BGP, and QoS monitoring support. So all these kind of stuff will be used in metrics like where is needed to active, proactive uh, monitoring. Okay. And next is that best practices proactive monitoring within the IT operations. So there are totally 5 operations like where it's best used. So based on the above analysis, like we have some best 5 practices. See where a recommend the organization should follow to make their IT operations truly proactive. So first one is that uh, I mean, use some user experiencing monitoring, or you can go for some. Be sure to monitor early warning performance indicator, or use some auto baselining to simplify the OT operation, and at the time get early warning alerts, and ensure that your IT operations processes are aligned with your monitoring tools and your customer service level agreement. And being proactive or also includes intelligent capacity planning. So first one, user experience monitoring judiciously. So it is important that where uh, your IT administrators know about the problems before the users notice and comply. As we described above, users experience monitoring can provide indications of a problem, their application and infrastructure. So with a 24/7 synthetic monitoring in place, they can begin working on a problem as soon as it is detected, and even resolve it before the majority of the users notices it. And be sure to monitor early warning performance indicators. As we saw in an earlier discussion, there are a set of metrics that can provide administrators early warning indicators. So make sure your monitoring tools are configured to track and alert on such indicators. And the third one is that use auto baselining to simplify the IT operations and at the same time get early warning alerts. So here, alerting based on some fixed threshold put too much burden on the IT admins to configure the right threshold. So modern monitoring tools have the ability to learn from the past history and to automatically set the baseline based on the norms of past performance and adapt such technologies as they will alert you to abnormal usage patterns that you may have been aware of otherwise. And next one is that ensure that your IT operations processes are aligned with your monitoring tools and your customer service level agreement. So proactive alerts are of no use if they're not acted upon. Once IT operation team get a flood of alerts, that over time they start to ignore the alerts from monitoring tool. Make sure that you're continuously assessing from the monitoring tool and turning it required to make sure all the alerts you receive are valid and will be acted upon. Being proactive also includes intelligent capacity planning. So here, the performance issues you may occur because of some insufficient capacity in some cases. So make sure you plan in advance so that you can augment the system capacity to avoid any potential issues down the line. Okay. Goals of proactive monitoring. So detect the unusual or risky behavior early and prevent the data breaches or some misuse, and ensure that compliance with the security policies. And last one, minimize the downtime and performance issues. Okay, so this is the goals of proactive monitoring. So where it's used, okay, like area and then example I have given. So here, area like a user behavior, like example detecting when an employee logs in from an unusual location or at odd hours, and network monitoring spotting abnormal data transfer from an unknown or IP connection, and cloud environment watching for unauthorized access to cloud storage. Example, AWS S3 bucket access, and application logs monitoring failed login attempt or strange API calls, and security systems tracking antivirus alerts, firewall blocks, or system changes. Okay, so what are the tools commonly used? So tools like SIEM, EDR, cloud monitoring tools, and then network monitoring tools like science that security information and event management. So here, like Splunk or IBM QR radar and EDR endpoint detection and response, like example like CloudStrike or Sentinel on, all those stuffs we'll be using. And next is that cloud monitoring tools. So here, what we'll be going is that example like AWS CloudWatch or Azure Monitor or network monitoring, like example Wireshark, Nagios, or SolarWinds. Okay, like the common features of these kind of proactive tools is that it uses in a real-time data collection and analysis and predictive analysis and alerting, and automated remediation or escalation, dashboard and visualization effect, integration with some other IT management system. So here they have given the diagram like the proactive monitoring strategy, where the proactive monitoring and then risk mitigation, operational efficiency followed by the performance enhancement. So where core strategy for organizational improvement or the identifying and addressing potential issues early, and streamlining processes for better performance and achieving some goals more effectively. So examples of proactive monitoring applications like Datadog, Dynatrace, SolarWinds, Nagios, Zabbix, Prometheus, Grafana, Splunk, New Relic. Yes, like if you want to some specific category, say DevOps, so which is a uh, wide, widely or used like Gordon. Like for example, if you take DevOps, it's a proactive monitoring is essential to ensure the CI, that is continuous integration and continuous deployment pipeline, infrastructure and application which runs smoothly and issues are caught early. Like there is some list of top proactive monitoring applications for DevOps teams, like focus areas. Then first one, full stack observability, and APM, that is application performance monitoring. So these tools monitor everything from infrastructure to the application code, and Datadog like end-to-end observability for their work, real-time metrics, logs, traces, synthetic testing, and anomaly detection, great for microservices and containerized environments. And Dynatrace is that so AI-powered observability platform, auto discovery of dependencies and services, excellence for complex cloud-native applications, and New Relic like a unified monitoring across apps or infrastructure and user experience, and real-time alerts and AI-assisted issue detection, and infrastructure monitoring and alerting. So Prometheus, like Grafana, where Prometheus creates and stores time series metrics, whereas Grafana visualizes them, and ideal for Kubernetes and containerized environments, and highly customizable alerting and dashboards, and Zabbix like enterprise-grade monitoring for network servers or the cloud services, predictive trend analysis and anomaly detection, and Nagios like proven and customizable monitoring solution, and works well with plugin or CI/CD and alert integration, and CI/CD pipeline monitoring in that where it will be using some Jenkins monitoring plugins like monitoring plugin, Prometheus plugin, or monitor the job execution time where the queue sizes and failure rates will be calculated, and alerts via Slack, email, or dashboard, and Circle CI insights. So built-in analytics to monitor the job duration, failures, and fluckiness trends, and proactive alerts for pipeline slowdown or outages, and GitLab CI/CD monitoring, which integrates with the Prometheus for built-in performance metrics, which tracks the pipeline efficiency and resource consumption, and log and event monitoring like ELSK Stat, Elasticsearch, or Logstash Kibana, centralized logging and real-time search. So Kibana, a dashboard, allows proactive spotting of trend or issue, and Splunk, a real-time log and mission data analytics, and great for identifying and resolving anomalies before they escalate, and cloud native or Kubernetes monitoring. So here, the Kubernetes dashboard like Prometheus plus Grafana, which shows up the live metrics as well as health checks for pods, nodes, and services, and alerts for memory or CPU spikes, pod restores, or node failures. Lens like Kubernetes IDE that provides real-time cluster insights and useful for proactively managing multi-cluster environments, and AWS CloudWatch and Azure Monitor like GCP operation, formerly like Stack Driver. What they'll be doing is that just provide some native tools for cloud resource monitoring, as well as what they'll be doing is that it provides alerts and integration with DevOps tools. Okay, so this is all about the proactive monitoring real-time application. So what are the key components like involved in this particular proactive monitoring? Yes, proactive, it involves continuous observation and analysis of process, system, and behavior to detect the anomalies, and inefficiency before they lead to some significant problems. So unlike reactive monitoring, which addresses the issues after they occur, so it focuses on some prevention as well as early intervention. So first one, key components like it goes for some data collection and analysis tools and real-time alerts, and then feedback loop. So here a data collection. So what it will be doing, it gathers relevant data from various sources, including the user activity, system performance metrics, and environmental factors. An analysis tool here, it utilizes advanced analytics and machine learning algorithms to interpret data and identify the patterns or the anomalies. And real-time alerts, it implements the alert system that notify the stakeholders of the potential issue as they arise, allowing for some immediate action and feedback loop. So here it establishes some mechanism for continuous improvement based on some insights gained from the monitoring activities. Okay. Next one is that benefits of proactive activity monitoring. So risk mitigation, improved efficiency, enhanced decision making, as well as customer satisfaction. So here, risk mitigation by identifying some potential risk early. Organizations can implement the strategies to reduce them, reducing the likelihood of costly disruptions and improve efficiency. So here, continuous monitoring helps streamline processes, lead to enhance productivity as well as resource utilization and enhance decision making. It involves access to some real-time data and insights allows for informed decision making, fostering a more agile organizational response and customer satisfaction. Proactive monitoring can lead to some improved service delivery or enhancing the customer experiences and satisfaction. Okay, so these are the benefits. And next one, like implementation strategies. So here it defines the objective and also it selects the appropriate tools and train the personnel and then regular review as well as adaptation. So what is meant by objective is that it clearly outlines the goals of the monitoring activities to ensure the alignment with some organizational priorities. So select the appropriate tool needs. Choose a monitoring tool that fit the specific needs of the organization, considering factors such as scalability and integration capabilities. And to train the personnel, you have to equip the staff with the necessary skills and knowledge to utilize the monitoring tools effectively and respond to alerts appropriately. Regular review and adaptation continuously assess the effectiveness of monitoring strategies and adapt them as necessary to meet some evolving organizational needs. And there are like proactive monitoring is powerful, right? But it's not without its downside. So there are some key drawbacks which you have to keep in mind. The first one is that it is a high complexity. So setting up proactive monitoring, especially across distributed system like microservices or hybrid cloud, can be technically complex. It requires to threshold alert rule and metric collection, which can be time consuming. So alert fatigue, like poorly configured system may generate too many alerts, including some false positive. So DevOps team can become desensitized, potentially missing some real issues. Third drawback, like resource intensive. So monitoring agents and logging tools can consume CPU, memory, and storage. So a data collection and analysis may add some overhead to the infrastructure. Like cost wise, if you take like enterprise monitoring tools like Datadog or Splunk or Dynatrace can be very expensive, especially as the data volume grows. In such cases, licensing, data retention, and integration may incur additional charges also. And steep learning curve. Some tools, have a complex setup and configuration process. It requires skilled personnel to maintain and fine-tune the systems for the optimal value. And over-reliance on tools like Teams might rely too heavily on some monitoring tools instead of understanding underlying system behavior. It can reduce the incentive to improve the code quality or the architecture if monitoring will catch it. Data noise and blind spots. Too much data without the context can lead to information overload, right? So some events might still go undetected, or especially if metrics or logs aren't properly defined. So this is all about proactive monitoring. So next topic we are gonna see is that cloud incident response. So here, the cloud instant response is a strategy for addressing the security threats in cloud environments. It involves quickly detecting, assessing, containing, and resolving threats to minimize the harm to workloads and restore some normal business operations. So, unlike traditional instant response or cloud instant response, it inspires the unique aspects of a cloud system, such as distributed architecture, shared responsibility between the providers and customers, and scalable flexibility. So why this cloud instant response is important? Like, it reduces the effects of incidents and supports compliance with some regulatory standard, so thus preserving the trust. And well-designed code or IR strategies can significantly decrease the downtime and financial losses while strengthening the overall security posture. By tackling current threats and consistently uncovering the vulnerabilities and opportunities for enhancement. And this instant response is part of detect and the response strategy in the cloud security lifecycle. So these stages align with, you know, uh, it aligns with some cloud security frameworks such as NIST, Cyber Security Framework or CIS control, which outline a comprehensive approach for security cloud environment. And apart from that, this cloud instant response will be used in the process where key phases are there in this particular cloud instant response, like preparation, detection and analysis, containment, eradication and recovery, as well as post-incident review. So here, what is meant by preparation is that, so it defines the roles, responsibilities, and escalation paths. So we have to develop the run books and incident playbooks for the common scenarios, example data breach or DDoS, and we have to implement the logging, monitoring, and alerting, example like AWS Cloud Trial as well as Azure Monitor. And last one, use identity and access management like IAM. We have to use some best practices like least privilege or MFA. The second one, detection and analysis. Like we have to use some proactive monitoring tools like what we have discussed in the early slide, like CloudWatch, Splunk, Sentinel, like all kind of SIM tool to detect the anomalies and analyze the logs, network traffics, as well as the audit trials. And containment is that we have to isolate the affected systems, example, revoke the credential or quarantine instances, like limit the damage and prevent the instant from spreading. Okay. And eradication and recovery is that it removes the malicious artifacts, example, malware or raw containers, or patch the vulnerabilities or the misconfiguration, and we have to restore the services using some clean backup or redeploy the infrastructure. And post incident review, like conduct a root cause analysis, identify the gaps in detection, response or policy, and update the run books and tools based on some lessons learned. And there are some specific cloud consideration where it is used, like shared responsibility, ephemeral resources, multi-tenancy, as well as automation. In case of a shared responsibility, you can go through some cloud providers, secure the infrastructure, but customers must secure the configuration, access, and data. In ephemeral resources, instances and container can disappear quickly. So, logging and snapshots are essential. In multi-tenancy, attacks could exploit some misconfiguration across tenants if not properly isolated. Okay. And in automation, we have to use AWS Lambda or Azure functions or Cloud GCP function to automate the instant response. Okay. And what are the common cloud incidents. So a cloud security incident is a security event that comprises the confidentiality, integrity, or availability of data or application or the services hosted in a cloud environment. So it can result from cyber attacks, misconfiguration, or unauthorized access or vulnerability specific to some cloud infrastructure. So here they have given some of the uh, common cloud instance. First one, data breaches. Second one, account compromise. Third one, misconfiguration. And next one, DOS attack, and then malware and ransom attack, and then insider threat, and then last one is then crypto jacking. Okay, so these all comes under the common tools which is used here. So apart from that, there are tools like for common clouds like AWS, Azure, GCP, or cross platform like Palo, Alto, Prisma, Sumo, CrowdStrike. All those things also comes under uh, these cloud incident response. And if you take, drawbacks, right? So drawbacks, it involves like shared responsibility confusion. Like many teams misunderstand who's responsible for what, misconfiguration or often the customer's fault but blamed on the cloud provider. Second one, limited visibility. So the cloud provider may not give full access to the underlying infrastructure or the logs, and some logs, example cloud trial, audit enabled by default or expensive to scale. And volatile or transient responses, cloud environments are dynamic. So here instances, containers or functions may spin up or down quickly. If logs or snapshots aren't collected immediately, so key evidence can be lost. Okay, and then tool sprawl, like this is a new word we have not here, I think so. So here, cloud native and third-party tools are often needed across the multiple platforms, and managing integration and keeping everything in synchronized can be a nightmare. In forensic challenges, traditional forensic method like disk imaging or memory dumps are harder or impossible in the cloud. But cloud native forensics requires some specialized knowledge as well as tools, and compliance and legal issues. So jurisdictional concerns around data sovereignty and log storage, and cloud instance may impact the customers in multiple regions, complicating notification and response. And it's like skill gaps. So not all security teams are trained in the cloud specific instant response. So tools, API, and cloud service are constantly evolving, which requires ongoing learning. Okay, and cost wise, if you take instant response in the cloud can trigger additional cost, example log retrieval, snapshot, or forensic analysis, and post immediate remediation might require spinning up additional secure infrastructure. Okay, so here in this particular video we have discussed about the proactive monitoring and what are the industry standards for proactive monitoring, and what is why synthetic monitoring is useful but not sufficient for proactive monitoring, and what is needed for true proactive IT monitoring. And we have discussed about the best practices which is used in IT operations, and then the goals of proactive monitoring, where it is used, and the tools commonly used for proactive monitoring, and what are the key components involved, and what are the benefits, and what are the drawbacks of it, and what are the implementation strategies of it. And next we have discussed about what is the cloud instant response and why it is important, and what are the cloud security instance, and then common cloud instance in this particular video. I hope we have a clear idea on this topic. We will see in the next video. Thank you all.